Greetings everyone. Welcome to another lecture of Circuits and Systems. In today's lecture, we are going to talk about Hurwitz polynomial. So, starting up with introduction of synthesis, properties of Hurwitz and few practice question. So, there is a famous saying which says there are no secrets to success. So, you can achieve success by preparation, hard work and learning from your failure. So, you just need to prepare, you need to prepare hard and you have to learn from a failure to get the success. So starting up with network synthesis. So what we say, we have three things in an electrical network. We have input, we have function, network function, or that is nothing but the transfer function of the network, and we have an output. So according to the things, if we already know the network, the existing network, we know the input, we can derive the output. This is known as my network analysis. So for the network analysis, we know the input, we already have a network, we're trying to calculate the output. On the contrary, what is network synthesis? In network synthesis, what do we have is, we know the input, we know the output we want, but we don't know what this network is going to be. So for that, we try to calculate this using our maths. Okay, so we get a transfer function. But what about this transfer function? Mathematically, everything is possible. Mathematically, time is defined from minus infinity to plus infinity, but it is not. So we just need to check whether this transfer function is actually realizable or not. So that part is known as network synthesis. So for network synthesis, there are two important things which we need to remember. First, causality. Second, stability. So what is causality? As we already know, for response of any network for t less than 0 is going to be 0. That means the network is causal. And for stability, we have different tests for stability. So one of the tests is Hurwitz polynomial. So for any polynomial, if it is an Hurwitz polynomial, that characteristic equation represent a stable linear system. So Hurwitz polynomial, a polynomial is called as Hurwitz polynomial, then we are sure that it's going to be for a stable linear system. So there are few properties of Hurwitz. At times in exam, they are directly asked, write down the properties of Hurwitz. So we are not discussing each other, we are not going to read it out, we are just making sure that these properties, take a screenshot of these properties, try and go through it once, and then in the subsequent numericals we'll be discussing almost all the properties. Okay, so the first property says all the coefficient of Hurwitz polynomials are positive, and polynomial may not have any missing term between the highest and the lowest order unless there is a point to it. It is an even or all odd terms are missing. So let us see. Let us say we have a PS, a Hurwitz polynomial. Let us say S4, S3, S2, S1, and S0. These are the powers of the polynomial. So if this thing exists, and let us say this S1 term will not exist, then we can straight away say that PS is not an Hurwitz polynomial because there is a term missing between the highest and the lowest order. But if we have S4, S2 and S0, or we have S3, S1, we have these two polynomials. They may and may not be Hurwitz, but we cannot rule them out from not being Hurwitz because here all odd terms are missing, here all even terms are missing. So this is one. So these properties are going to help us to determine that Hurwitz polynomial, the polynomial given to us, is Hurwitz or not. So let us begin. Let us see the two questions. So first part, PS. Let us roll it A and B. So part A. So just look at the equation. Can anyone tell me whether it's Hurwitz or not? Just look at it. Go through it once. Yes, it is not an Hurwitz polynomial. Why? Because if you see it carefully, term of s square is missing. That is why it is not an Hurwitz polynomial. Then part B, it is not an Hurwitz polynomial. If you see, there is a negative coefficient to a Hurwitz polynomial. This is also not an Hurwitz polynomial. So what exactly my Hurwitz polynomial is telling? What my Hurwitz polynomial is trying to tell me is Hurwitz polynomial, if all the coefficients are positive, that means that is all the poles lie on left hand side of S plane. That means all the poles are stable poles. So let us go through with few more questions. Let us check out. Now, first property, all the terms are there. Yes, it is there. Second property, is there any negative term? No. Then how do we check? So for this, we make a Routh-Hurwitz table. Hurwitz table. So what it is just draw from the highest power of S, that is S4, S3, S2, 1, S0. Start writing the all the even terms. So this is 1, 6, and 8. Then we have got 7, 21, and 0. Okay, now we need to calculate these terms. What are the subsequent terms? So for the first term, let's just call it as okay, let's name this row as A, this row as B, this row as C. Just for the understanding sake, I'm trying to tell you. So what would be my, let's put this positions as 0, 1, 2. So what would be my C0? So I'll just write down the formula. My C0 is going to be B0 multiplied by A1 minus A0 multiplied by B1 whole divided by B0. So it would be 7 into 6, that is 42, minus 1 into 21, that is 21, divided by 7. So my C0 will be is equals to 3. Let's just write down 3. Moving ahead, what about my C1? My C1 will be B0 multiplied by A2 minus A0 multiplied by B2 divided by B0. So it would be B0, that is 7, multiplied by 8, 2, that is 8, 7 8s are 56. 1 multiplied by 0 is 0, divided by 7, this is 8. So we've got 8. Last term will still remains 0. Okay, so now moving ahead to the next term, s raised to the power 1, that is coefficient for D. So it would be, we are concerned with row B and row C. In the very same order, we'll start with this thing. So we'll start with D is equals to C0 into B1. Okay, so now moving on to the D part. For this, we are concerned with row B and row C. So for D0, we need C0 into B1 minus B0 into C1 divided by C0. So it is 3 into 21 minus 7 into 8 that would be 56 divided by 3. So it would be 63 minus 56 divided by 3. This becomes 7 by 3. Now next two term will automatically be 0. Okay. So moving on to the last coefficient. Again, it would be this and this. This will bring me 3 into 0, 0. 7 into 3 divided by 7 by 3. This will get me 8. So now this whole Hurwitz table is complete. That means now we can judge whether Raoult's table it is a Hurwitz polynomial or not. If you can see, all the coefficient in the very first column are positive. If all the coefficient in the very first column are positive, that means my polynomial is an Hurwitz polynomial. Okay, so just take a screenshot of it. We'll go ahead. Okay, now moving ahead to the next question. So we have another polynomial. Here also, all the criteria of the polynomial satisfies. There are all the powers, all the coefficients are positive. So let us just try for this once again. So it is 1, 2 and 2. Then we have got S4, S3, S2, S1, 0. Just go through with the questions. All the questions are different. All the questions are going to give you different result and going to satisfy the different properties. Okay. So then we have got 1. We have got 3, then we have got, okay, for odd part 1, 3 and 0. So S1, 1 into 2 minus 1 into 3 divided by 1. So this is going to be 1 into 2 is 2, 2 minus 3 is minus 1. Okay, 1 into 2, 2, 1 into 0, 2, again this would be 2. Okay, so if you want to see once again, so this would be, this point will be 1 multiplied by 2 minus 1 multiplied by 3 divided by 1. This is going to be minus 1. Okay. So this is for the term for S2. I'll just write it very clearly. This is for S raised to the power 2. Now, I've just marked this one for you. Let's go with S1. Minus 1 into 3, it would be minus 3. 1 into 2, it would be minus 2 divided by minus 1. So minus 3 minus 2 is minus 5 divided by minus 1. It's cancelled. This is 5. Rest all will be zeros. Similarly, we can calculate for S0. Minus 1, 5 into 2 divided by 2. So this is going to be the Raoult's table. Now, if you can see the term which is circled, this has got a negative sign associated with it. Any column, in first column, any number having a minus sign, that means this is not going to be my Hurwitz polynomial. That is, there is at least one pole for this which is going to be lying on right hand side of S plane. Okay, so negative sign means one pole will lie on the right hand side of the S plane. That means my system is unstable. Hence, it is not an Hurwitz polynomial. Moving ahead. Now you see, now we have got the property again. Now the property kicks in that there is no even term. So we told you if either there is all odd terms or there is all even terms, that polynomial may be an Hurwitz polynomial. So for solving this, what we need to calculate, we need to calculate P dash S, that is nothing but d by PS, d by ds of PS. So this is going to give me 5S4 plus 3S square plus 1. Okay. So now I've got all the coefficients of numbers which require from highest to the lowest power. So we have got S5, S4, S3, S2, S1, S0. So S5 it is 1, 1. For S is equals to 1, it is 1. Then we have got 5, 3, and 1. Okay, start calculating the Hurwitz polynomial again. 5 into 1, 1 into 3, 1 into 3, 3, 5 into 1, 5, 5 minus 3 is 2, 2 by 5. Again, 5 into 1, 5, 1 into 1, 5 minus 1 is 4. This becomes 4 by 5. This is 0. Now, we'll calculate for this. 2 by 5, that is nothing but it is 0 0.4. 0 0.4 into 3 minus 0 0.8 into 5 divided by 0 0.4. So if you see it carefully, this factor is going to be negative because 0 0.8 into 5 is going to be bigger than 0.4 of a 3. So if you still want to know, let us say 4 into 0.4 into 3 is 1.2 minus 0.8 into 5 is 4. 4 minus 1.2 is going to be 2.8 divided by 0 0.4. So as soon as this becomes negative, this is not going to be an Hurwitz polynomial. So for Hurwitz polynomial, this term is not going to be negative. Okay. So moving on to the next question. Now we have a question. PS is equals to this. Now all the powers are there. Okay. So let us just check out whether this is going to be an Hurwitz polynomial or not. So we have got 1, 45, 44, 12, 60 and 48. This is S5, 4, 3, 2, 1 is not. This is also a different question. All questions may seems to be similar, but there is one catch to the question. So just what you can do is you can just start calculating with me. Okay. So 12 into 45 into 1 minus 1 into 60 divided by 12. So this is going to be 12 into 45 minus 60 divided by 12. So what I can do is I can take 12 common. We have got 45. Okay. No, 12 cannot be taken as common. You can take 15 common. Just to solve this, I've taken 15 common. So 12 into 3 minus 4 divided by 12. So 15, 12 into 3 is your 36, 32 divided by 12. So 3, 5, 3, 4, 4, 4, 8. This is 40. Okay. Now for this and this, you'll calculate. This will also come as 40. Okay. I already have the values. Okay. Again, moving ahead. Next, when you solve the next part, you get 48, you get 48, there's 0. Now comes the interesting part. See, these are the values which I've already calculated. You can calculate and check. May and may not be correct also. So even teachers can make mistake, right? So this part, if you see all the values are same, this is going to yield you all zeros. Now comes the new catch. This is going to yield you all zeros. Any polynomial cannot end at any junction without reaching all the values in the first column. Now how to go ahead with this? So for this, we'll just take this as an arbitrary polynomial where it has ended. So it is nothing but 48s square plus 48s. We have got the ds. Now to get the term, we need to get ds dash. So d by ds of ds will get this thing as 96s. So I've got my other term. So my s1 will be 96 and this all becomes 0. Now I can calculate s0. So 98 this and I'm going to get 96 again. All the terms in my first column are positive. Hence, this is also an Hurwitz polynomial. Okay, moving ahead to the next question. Let's see this question again. So this is going to be another good question which has got, okay, there is an error in the question. Just replace, sorry, replace this 4 by 2. Okay, so let's just plot the Hurwitz table for it. 2, 4, no, 2, 2, 4. You have got 4 and 4, 0. So this is S4 and this is S3. So let's calculate for S2. So S2, if you see 4 into 2, 8, 2 into 4, 8, 8 minus 8 is going to be 0. Let's take the other one. 4 into 4, 4, 2 into 0, 0, 4 minus 0 by 4 is going to, 16 minus 0 by 4 is going to be 4 again. Now, if you see, this term has come out to be 0. Now, there's a difference. All zeros and just one term being 0. If it had been all 0, we would have gone with the differentiation of S3. Okay. Now we just have one term as 0. So instead of solving it here, we have introduced new S2. Let's put it as S2 cap, and I'll just place a new variable called zeta, and I'll use this S2 instead of this S2 for calculation, and we'll see what can be the possible value of zeta, so that we can judge whether this polynomial is an Hurwitz polynomial or not. Okay, so now S1, zeta into 4 minus 4 into 4, 16 divided by zeta. Okay, next term, zeta into 0, 4 into 0 is going to be 0. Now S naught, S naught, zeta into this is going to be 0, this into this divided by this is going to be 4. So we have got two terms where this zeta is associated. So now let us check for limit zeta tending to 0, zeta s square plus 4. For limit zeta tending to 0, this term will be tending to 0. If this term is tending to 0, the resultant will be plus 4. Still, this will be a positive polynomial. Okay, it would be a positive coefficient, right? So moving to the S1, let's say limit zeta tending to 0, zeta 4 zeta by zeta minus 16 by zeta, zeta gets cancelled. So zeta tending to 0, it would be 4 minus infinity. It can be driven to the infinity. So this term can be a negative term. So if this can be a negative term, this whole is not an Hurwitz polynomial. Okay. So remember, if we get 0 at any point in the first column and the whole row has got other values. See, if this would have been also been 0, then again we should have differentiated the earlier part. We would have calculated the coefficients and carried on as we did in the previous question. So now just the last type of question. Okay, another question. Again, all terms are even. Okay, all my terms are even over here. Okay, so let us just see what's new in this question. We have got 1, we have got 4, we have got 2. Okay, so we need to calculate for, again, we need d by ds of ps. Okay, so it would be 6s5 plus 4s cube plus 2s plus 0. So we have got the new coefficient as 6, 4, 2. Okay, so these will be the coefficients. Okay, rather sorry. So we have this another question. We have all even terms. So we need to calculate d by ds of our ps. This will give me 6s5 This will give me 16s cube plus 4s plus 0. Okay, so we have got the terms. Okay, moving to the next question. So we have another question where all the terms are even. So we need to calculate d by ds of ps. So this is going to be 6 s raised to the power 5 plus 16 s raised to the power 3 plus 10 s plus 0. So now I've got all the terms. Let us just create an Hurwitz table. So we have got S6, S5, S4, S3, S2, S1, S0. So S6 will be your 1, 4, 5, 2. Then we have got 6, 16, 10, and 0. So 1 into 16 minus this. This will give me 4 by 3. 1 into 5 into this will give me 10 by 3, and this term will be 2. So moving ahead, this and this is going to give me 1 and 1. Okay, and moving ahead, this will give me 2 and 2. Okay, so my point for this question is, now here again S1 will have 2 zeros. So I wanted you to reach this point. So if we have again 2 zeros, according to the previous rule, what we would have done, we would have taken 2s square plus 2, again differentiated it, it would have been 4s. No, we cannot use this thing because we have already used the dummy polynomial form to calculate. We have already differentiated this polynomial to get all the coefficient of odd terms. So remember this thing, this process can be done only once. So if again all the 2 zeros are coming, then we can say this PS is not an Hurwitz polynomial. So these are the all possible questions of Hurwitz polynomial. Let's go and just check it once again. So we have got the first case. What happened was term of s square was missing, but they were even and odd. Both the terms were there. Even s5 was missing. Okay. So we have s5 and s4 s3 missing. That is why it's not an Hurwitz polynomial. Second part, there was a negative term. So it's not an Hurwitz polynomial. Moving to the next table, it was a simple case. We tried to create a Routh-Hurwitz table. All the values in the first columns are positive. Hence, it was considered as Hurwitz polynomial. So I'll just write it is an Hurwitz polynomial. Moving ahead, we got third term as negative. So it was not an Hurwitz polynomial. Next type of question was, there was all odd terms, and when they were all odd terms, so what we did, we differentiated this PS. When we differentiated this PS, we got the term in the form of even coefficients. We got all the coefficients, we measured, but unfortunately here again we got a negative term, hence not an Hurwitz polynomial. Moving ahead, we did all the same things, but if the complete row is 0, then the process changes. We pick up the value from the previous row, we differentiate it, we get the polynomial, we start calculating ahead. If all the rows are positive, it becomes an Hurwitz polynomial. The next type of question was where only one term in the column we were getting a 0. So what we did, we took a dummy variable zeta, calculated all the coefficient, tried to calculate if zeta tends to 0, then what we are getting. If we are getting both the, we would have got both the values positive, then it would have been Hurwitz polynomial, but the second value we got was negative, hence it is not a Hurwitz polynomial. Last question, That was all even coefficients were given. We calculated the odd coefficients, but when before ending it till S0, we got all the coefficients to be 0, which is not possible. And we cannot repeat the process of differentiation again in the complete question. Hence, this is also not an Hurwitz polynomial. This ends all the questions of Hurwitz polynomial. And always remember, guys, many a little makes a mickle. So I would like you all to like, share and subscribe the channel and let this universe of education grow a lot. Thank you. And yeah, you can write down your comments if you want to ask any doubt related to the question or the topic. Thank you.